With the complements defined, now we study how to achieve a subtraction out of addition operations with the complements. Suppose we have two numbers x and y. Each of the two numbers has n digits. So we have a number of digits defined here, n. Then if we add radix complements of y to x, then this is the expression. We can rewrite this expression this way: x minus y plus r to the n. Then what we can observe here is in the two cases. If x is greater than y, then x minus y is positive. Then r to the n exceeds the number of digits defined here. What I mean by that is as follows. Suppose x is 56 and y is 23. Then instead of subtracting 23 directly from 56, we first calculate tens complement of 23 and then add it to 56. That's what this expression says. So tens complement of 23 is, if we first calculate nines complement, that is 76 is nines complement. So if we add 1, 77 is tens complement. So if we add 77 and 56, then result is 133 is the result. So what 133 is, this portion, that is r to the n plus difference of x and y. So here number of digits is 2 in this case. So 10 to the 2 is 100. So 100 is r to the n part, which exceeds the number of digits we are working on now. The remaining number 33 is a difference of x and y. So which is originally we wanted to calculate the difference, a subtraction of 56 and 23. We get 33 the result. So we achieve subtraction of two numbers by adding r's complement of a number. So when x is greater than y, the result is discarded if the sum produces the number of digits beyond the number of digits defined. It's automatically discarded, and the remaining value becomes the result of subtraction. However, if x is less than y, x minus y is negative, so this portion r to the n may not be exceeding the number of digits, so we should take care of that case differently. So if x is less than y, suppose we want to do 23 minus 56, then x is less than y, so this case does not work directly as we did previously. But if we add r's complement of y, we can rewrite the equation this way. By the definition of a radix complement, r to the n minus something is a radix complement of something. So the whole result of adding r's complement of y in case y is greater than x, the result is r's complement of difference of y and x. So from this two number, if we follow that procedure, so 23, and then we add tens complement of 56. Tens complement of 56 is first nines complement is 43. So 44 is a tens complement of 56. And the result of adding tens complement of 56 is 67. Then what's the meaning of 67? Meaning of 67 is tens complement of difference of 56 and 23. Let me explain this one again. From this formula, what you can see is that if we add r's complement of y to x, where y is greater than x, then the result is r's complement of y and x difference. So in this example, the meaning of 56 is tens complement of 56 and then 23 difference. So if we take tens complement of 67 again, tens complement of 67 is 33. 33 is tens complement of 67. So what is meaning of 33 is difference between 56 and then 23. So in case y is smaller or greater than x, then the result of 67 represents the 10r's complement of the difference. So we get 10's complement again, 33, and we put negative sign as a result. So negative 33 is the result of subtraction. So this is a little bit complicated, but let's take a look at the example here. So if we subtract those two numbers, in case x is greater than y, then it's quite straightforward. Instead of subtracting this number, calculate the tens complement of y and then add it. Then this number is beyond the number of digits defined, so the remaining value becomes a subtraction result. But in case y is greater than x, but anyway we add the tens complement of y, then meaning of the sum 30718 is meaning of this result is tens complement of the difference, as we discussed in the previous slide. So meaning of this value is a tens complement of the difference. So we calculate the tens complement of the result again, then that is 69282. But remember, we are doing negative result, so we put negative sign in front of that. That's a result of the subtraction. Similarly, we can do for binary numbers. So we have two binary number. We want to calculate the subtraction x minus y. Here x is greater than y. So what you do is follow straightforward. We have x, and we add 2's complement of y. Then sum exceeds the number of digits defined. So we discard this part, and the remaining part becomes a subtraction result. But in case this number is greater, then we expect a negative result. Don't forget that. So we add 2's complement of this number, then we have a result. Remember, when we expect a negative result, the value, what you get here is 2's complement of the difference. So the answer is we need to find the 2's complement again, and then we put negative sign. So this is how we get result of a subtraction from adding radix complements.